Okay, right. So fantastic first talk from Oliver. So hopefully we'll have now an equally fantastic one from Tyler McMullen. I'll get his name right this time, having learnt it over the break. Tyler is CTO of Fastly. Is correct? Yeah. Unfortunately, if anybody here has been to things like Velocity and that before, you might have come across like Artur Bergman, who's kind of like the founder of Fastly. He was due to give this talk, but he is really, really sick. And Tyler stepped in at the last minute and sort of like flew over, especially to give this talk, and as well as deal with other stuff, I'm sure. But really looking forward to this talk around basically what we can learn in terms of web performance and stuff, in terms of what people that kind of like look after CDNs do. So without any more ado, I'll hand over to Tyler and we'll crack on.
So Artur does send his regards. Yeah, I know. Artur does send his regards, and he kind of ruined the story there where, you know, I did fly over. But basically what I was going to say is that I had this horrible nightmare the other day that I was on stage after flying across the world, horribly jet lagged, giving someone else's talk at the last second. And then it turned out it was true. So this is a very wordy title that Artur wrote. But basically what this talk is a bunch of lessons that we've learned over the past 4.5 years of running a CDN. So I'm going to start out with like the most, I keep forgetting the word, the one that everybody's going to disagree with to start with. I'm just going to jump right into like the different lessons that we've learned, which is that people use their CDNs wrong. My argument is this. So CDNs offer a tool set, right? It's not actually a black box, but I think a lot of people treat CDNs as a black box. It's a thing that requests go into, requests go into from your users, requests go out of to your servers, responses from your servers come into, and responses out of go back to your users. But that's not really strictly true. CDNs actually offer a variety of different things, not just Fastly, but like every CDN. It's actually a pretty advanced, pretty powerful tool set. And you can, like most powerful tool sets, you can drop them on your foot, you can shoot yourself in the foot, you can do all sorts of things that go really, really poorly. So the thing is, the configuration for this really isn't trivial. There's a lot of like fiddly bits that go into it. And of course, like if you just go to Fastly and you sign up and you say, okay, here's my domain name, here's my like origin IPs, we should do something reasonable. And we do, we follow the RFCs. But every site is different. And like little tweaks can make a pretty big difference for the positive or for the negative, right? It's very easy to exacerbate your problems. So here's one that I thought was kind of funny. It's a pretty interesting example. So is everyone here familiar with BigQueries? So BigQueries is a site basically lets you use Google BigQuery to like query a bunch of like public data sets, right? One of which is the HTTP archive. So what this person did was they looked up to find everyone who was serving their images with gzip, right? So everybody knows that like serving images with gzip is like basically a very silly thing to do. Like it's almost certainly going to increase the size of the files. It's going to increase the work on your server. It's going to increase the work on the browser side as well. But the interesting thing about this is, and this is not at all to pick on anyone in particular, but the majority of the domains that are listed there are actually CDNs. And I'm sure if you scroll down far enough, you would also see Fastly there. But the question is like, is it really the CDN's fault that this is happening, right? If you treat your CDN as a black box, it means that like occasionally things like this will happen, right? And so undoubtedly, like you certainly shouldn't be doing this by default, right? And certainly if you sign up for Fastly, it's not a thing that we do by default, but it's a very easy mistake to make. There's a bunch of mistakes like this, a bunch of like simple examples that can make or break the speed of a site, right? So caching headers, right? Is everyone familiar with the smaxage cache control header? Right, okay, so this is really cool. So there's maxage, which everybody knows. Maxage like controls the TTL that like your browser caches content with, right? smaxage actually controls the surrogate maxage. So the CDN in this case is the surrogate. It's the like server that the content is passing through on the way. And so you can control specifically the TTL with which the content is cached on the CDN versus in the browser. And this is actually fairly powerful because what it means is that you might be caching your content for only like a fairly short period of time because you might not know when it's going to change, right? It may be a thing that you only cache for like half an hour, even though it really only is likely to change like every day or so, right? But you don't know when it's going to change, so you have to cache it for a smaller period of time. With the surrogate max age, what you can do is say, okay, CDN, you can cache this forever. You can cache this for a long time, and then when it changes, I'll purge you. Meanwhile, the clients can be caching it for a shorter period, and when they go to fetch the content, the CDN will either have the new content or not. Another thing that we see pretty often is bad TCP connection management at origins. So like one of the other things that is a really big advantage of using a CDN is that even for content that is a miss or is a pass, essentially, like so content that can't be cached or isn't cached currently, CDNs can make a big difference because when you do that TCP connection, when you start doing the handshake, the SSL handshake and all, you're doing that with a node that is much closer to the user, right? And so it's like fewer, or it's the same number of round trips, but they're much quicker round trips, right? And then, in theory anyway, the CDN is actually keeping open a connection to your origin, right? So in theory, you shouldn't actually have to go and reestablish that connection for every new user that comes in. But it's actually a pretty common thing for web servers to close that connection either right after a request is responded to or pretty quickly thereafter, right? And so this can actually make a pretty big difference as well. By keeping those connections open for a long period of time, can actually reduce the amount of time that users are waiting. And then another one, which I'm not actually sure why Arthur put this in here. I haven't actually seen this one before, but like origins not gzipping content, right? There's still that period of time that it takes for the origins to send the content back to the CDN. And by gzipping the content at the origin, you can reduce that amount of time as well. So basically, this is all to say, CDNs give you a tool set, and with great power comes great responsibility. So lesson 2, I guess. Dynamic content is really interesting. So this is going back to that content that I was just referring to that can't be cached, or theoretically can't be cached, right? So what is dynamic content? Stuff that's not static. Great. OK, not a very useful definition. OK, but the biggest thing, and this is like kind of a classic type thing that has always been happening on the web, is that even if you're using a CDN, or even if you're caching your content, typically people aren't caching like the base HTML of their site, that initial response that comes back from servers, like that ends up building the rest of your page, right? So, which ends up in waterfalls that look like this, right? Where basically everything has to wait until that time to first byte finally elapses there. Because it's blocking on that, right? You can't actually start loading any other content until you start getting the content from that HTML page, right? And so with dynamic content, classically, anyway, you can't cache this. And so why is that? Why can't you cache something like this? Well, I believe it actually comes down to caching versus invalidation. And I think this goes back to the very beginning of the HTTP 1.1 days. And here is why I think this. So if you pull open the RFC 2616 and you search for the word cache, and you can't actually see that probably, it's kind of light, but search for the word cache, it comes up with 616 hits in that document. Cache is mentioned 616 times in RFC 2616. And then you go and you search for invalidate or invalidation, and it shows up 7 times. So clearly this was not like a big thing that people were worried about when they wrote like the HTTP 1.1 spec. And if you look at the times it is mentioned in RFC 2616, it's really limited. It doesn't really give you much of a framework for dealing with content that is changing that you need to remove from either the browser cache or from like surrogates in between. We did actually try at one point in the past. So this is the Web Cache Invalidation Protocol. Who has heard of the Web Cache Invalidation Protocol? Nobody, right? So this is from March 2001, and no one's heard of it, so we can basically assume this is dead. Right, so what is the problem with caching dynamic content? Well, the primary problem comes down to serving stale pages. There's other things that go along with it as well, like losing visibility into who is coming to your site and when they're showing up. There's logging as well that comes with that. But the biggest thing is really serving those stale pages. Like you really don't want to do that to your users. And so the way that CDNs have typically handled dynamic content has been by treating it as like a matter of transport. They look at it as part of the transport layer, as part of the TCP layer. And so like classically, and Fastly does this as well, there's a lot of like middle mile optimizations. As that request comes in to one of our servers, We then are optimizing the TCP connections and making sure, like, shaving milliseconds off to make sure it gets from this node to this node back to your origin server as quickly as possible. And people have tried to do caching at this layer as well, but it's always been like small little pieces, and ESI falls into that, and ESI has problems I'm not going to get into. But I think a lot of times dynamic content is actually much more cacheable than we give it credit for, because I think there's multiple different kinds of dynamic content. There's the kind that really is changing on every single request. There's the kind that is like customized for every single individual user. But then there's just the kind that's actually static. It's just static for short, unknowable periods of time, right? So this is things like comments on web pages, right? Static until someone changes it. And so what we've started referring to this, at least inside Fastly, I've been trying to like get other people to think about using this term as well. Instead of calling this dynamic, what we've started referring to this as is event-driven content. So content that changes in response to an event that is coming from some source, some unknown source, right? So comments, you could cache sports scores, except then they change, right? But if you could cache this, there would be like a huge number of benefits, right? So faster time to first byte, which leads to faster rendering time, which leads to happier users. It also means less load on your servers. It also means less load on our servers, which would be lovely. So how would you go about doing this if you could? Well, I think we actually do need like an actual complete invalidation protocol for HTTP, but it doesn't exist yet. So basically what Fastly has done anyway has created create a like instantaneous, or as close to instantaneous as is possible, framework for doing this inside our CDN. And we hope that others will adopt this as well. But basically, at least with us, it takes about 150 milliseconds to get rid of a piece of content around the world. And so that actually fundamentally changes what you can cache and what you can't. Anyway, so next lesson. Measurement is still hard, right? So this is the part of the talk that I had like the least practice with, so please forgive me if I mess this part up. So right, measuring, when you're using a CDN, measuring it is actually a pretty big challenge, right? You can measure it from the client side of things, but that only gives you, well, of course it does give you the most important aspect, which is the client side aspect, but it doesn't tell you what your CDN is actually doing. You can get your cache hit ratio typically, but that still doesn't actually tell you everything you need to know. And I'll get into what I mean by that. So what it comes down to is that like the time to first byte out of data centers can actually be dramatically different, even if like we're talking about different misses or we're talking about different cache hits. And so I just wanted to be able to like test this, and like I think I can show this in a pretty easy way. So what I did is I set up, or rather Artur set up, or actually maybe Human set up. Anyway, somebody set up this test, and this is a real test that we did. We set up 3 different objects. We're actually pulling these objects from the same CDN, doesn't matter which CDN. And we're using Catchpoint to do this testing. And so what Catchpoint is, if people aren't aware, is essentially a tool for network testing. It also like does simulated browser testing, and oftentimes it will do this from individual homes around the world. And so what we did in this case is we set up a test that used every single Catchpoint node in the US, which in this case was like several thousand of them, just like actually located in people's homes making requests for us, which is kind of cool. And we did 11,500 of these tests across 3 different objects. And 3 different objects were essentially a very, very hot object, something that's being hit constantly, an object that is quite hot, like normal levels of hotness here, and then an object that's quite cold, so a long tail object. And so we're going to look at like the connect time and the wait time, the time to first byte. And I think you'll see where I'm going with this. So for the Sodexo object, this is like the really hot object. We see a connect time typically of about 14 milliseconds and 19 milliseconds for the wait time across 11,500 requests on average. It's pretty awesome. Then we look at the like moderately hot object. We see that the connect time is still the same, but the wait time is now different, which seems strange given that it's a hot object. It actually falls about 26% in this case. And then for the long tail object, for the cold object, we see that the wait time has actually gone up again. And so one of the interesting things about this data that came out of here is actually that it ends up falling into bands, right? And so for the Sodexo object, for this like really hot object, what we actually saw was the majority of time, that time to first byte would be about 19 milliseconds. And then there was another band of latency, which is about 24 milliseconds. Then there was another band, well, there was one particular request in this case that was a much higher, right? So there's that one outlier. And so what we believe what this actually is like a memory cache hit versus a disk cache hit versus a like mid-tier type cache hit, where it's actually not on the node that you're getting to and actually has to go fetch it from somewhere else. So essentially a miss. And if you look at the moderately hot object, you see something similar. Right? So about 20 milliseconds, 31, and 45. And for that long tail object, you see this as well. And so what's interesting is that like as the hotness of an object changes, you know, if you look at the hit ratios for all of these, especially between that Sodexo object and the moderately hot object, you see that the hit ratio doesn't actually change very much, right? But the average actual time that it takes to get back from the data center does, right? So this is all basically just to say that like you really need to be measuring the right thing. So in this case, like my argument is that cache hit ratio actually isn't enough if you're trying to measure your CDN, because not all cache hits are actually the same. Not all caching is the same. Okay, last lesson. CDNs are not solved, right? So this is something that I've heard a lot of over the past several years, which is like, why would you go build a new CDN? What is the point of that? Don't you know, like we've solved CDNs quite a long time ago, essentially is what people are saying. But my argument is that that's not actually true. So HTML and other dynamic content, we need to be caching more of. We need to be like building out solutions. We need to be working with like the W3C to come up with better ways of invalidating content, better ways of caching content, right? I think a lot of times we end up having like a worse cache hit ratio than we actually expect on CDNs and that we should be able to expect from CDNs. There's also the new challenges that mobile apps and APIs present, which for a lot of things, a lot of APIs are considered like non-cacheable. So what do you do? Right, so my argument is that there's lots of room for advancement in this area. And so you should be expecting to see like a lot of advancement from CDNs in the next several years as, you know, service workers, right? Like I've been like racking my brain trying to think, okay, how could we actually like take advantage of this new technology in order to like integrate with the CDN and do something interesting? And like if anybody has ideas for that, I'm all ears. But there's lots of room to be creative at the edge. And I think what you're going to start seeing over the next several years is CDNs stopping being just like caching layers and starting being like actual edge compute layers, where you start being able to do more and more interesting things at the edge. Because we have all this CPU that's sitting there right near the users. We should be using it to do more interesting things as well. And that's all I got. I think that was quicker than he was expecting. He's not here.
No, I think Perry's gone to get pizza.
Oh, he's going to get pizza.
I'll happily freestyle.
Okay. Happy to take questions.
Yes, I believe we definitely have time for questions, especially as pizzas aren't even here yet. So thank you very much, Tyler. That was incredibly interesting. So I think Simon, no, yeah, we've got a question there. Brilliant.
So apologies if this sounds a bit more of a sales question, but about 2 years ago we were looking at Fastly and really excited. But maybe this is a lie. But someone said that we didn't go with it because there was no like edge nodes or no servers inside the Chinese firewall. Is that true? And is it still the case if it was true?
That was true and continues to be true today. And that's actually true for most CDNs. There's actually very few that have their own CDN nodes inside of China. The vast majority of them partner with specifically Chinese CDNs, and we can't do that because we offer things that they don't. So we would just be like crippling ourselves. So we still don't. We're looking into it. We'll get there eventually, but it's really hard.
Hi, yeah, just interested by what you said right at the end there about using compute at the edge.
Yeah.
I'd heard a rumor that Amazon's CloudFront was was looking at doing JavaScript at the edge, and when I heard that, I thought, oh, that could be a game changer. But then I thought about it a bit more. I thought, actually, is that actually good? Because do you have the level of control out there that you really need? I mean, do you see that being the future, that people do things like that at the edge?
So follow-up question to that. What do you mean by control in this case?
I mean that your ability to perhaps release changes to that code or configuration changes perhaps aren't the same as your main platform at the origin.
Okay. I mean, I guess my argument against that would be that if you're running on like Amazon Web Services, you're running on EC2 or something, you're already relying on a third party to like run your code. How is this actually any different? But typically, like I know that CDNs in the past have had like very, very long like deploy periods if you're trying to change like what the behavior at the edge is. I think that's also something you're going to see change soon. So yeah.
Are you going to do JavaScript to the edge?
So we are not going to do JavaScript to the edge because I would not do a garbage collected language across like that many servers, honestly, is really what it comes down to, which I know is like fighting words in this particular room. So what we offer at the moment is VCL at the edge. And we'll probably do like more advanced languages in the future. I'm not sure what that's going to look like.
Michael, we can't, you're the competition. It's got to be a neutral question. Oh.
I work at Akamai, so.
Oh, great.
I read an interesting article, I think it was Max CDN, published something where they got some industry experts to talk about CDNs and their opinion. Yeah. And I think Ilya Grigoric came and said that a lot of them are just kind of following each other. So with that in mind, what are you guys innovating with in the next 12 years? Sell away.
Oh, that's a really good question. So I guess the things that we've talked about publicly, we're working on so things like, oh man, what can I actually say to this question? That's a really good one. Pass? Sorry. No, okay, so one thing that we're working on at the moment is like more advanced load balancing features, right? So basically the ability to do intelligent load balancing at the edge from everywhere. So this would let people do things like turn off their F5s, which would be pretty cool.
Yeah, that was a cheap blow, Mike. No. just doing some research.
No, I respect it.
Are there any more questions? I've got a question,
please.
Which is, I completely agree with you that it was very terrible that 1.1 or 2 have no spec invalidation. If you were to write the next HTTP spec and you wanted to include invalidation, what would that look for you? Obviously, Fastly uses the purge method or and header to do that. Would it be something along those lines, or would you reinvent it completely?
So I guess there are a couple things I would do. One would be like the really granular, like basically just a purge HTTP method, which is essentially like just get rid of the cache for this particular URI or this particular URI plus like vary settings and so on. Other things that I would love to see would be like surrogate key purging. So basically the ability to group content not just in a hierarchical way, but be able to say, okay, let's say you're running like an e-commerce shop, right? And you wanted to be able to get rid of every page that is a catalog page, let's say. And so what you would do is basically just like have a surrogate key header that is coming back from your origins, which would like be able to group those pieces of page or these pages together and then get rid of them all at once. That's something that I would love to see, something we implemented as well. But
you'll be happy to know that we use surrogate keys extensively on the new FT.
Yes.
This question over here.
How much do you see HTTP2 affecting CDNs with cache handling versus connection handling?
Man, I really wish the guy who has like been basically like studying HTTP2 inside Fastly for the last several months were here to be able to answer this question, because I can't answer it all that well. Honestly, I think HTTP2 has like a lot of really great ideas in it. I think it's going to be a giant pain in, I'm not allowed to swear, pain in the butt for CDNs in particular. And I know Akamai has implemented it to some extent at this point, but it makes a lot of things harder inside the CDN. Yeah, I'm not really sure. I can't really answer that one all the way. I'm sorry.
Cool. We got it. Yeah, got a question right at the back.
It's just really going on from what you just said there about, being a pain in the proverbials for CDNs. Why do CDNs offer it HTTP2 support then?
Oh, because people are demanding it.
Yeah, but if it's a problem, what are you doing about it?
I'm saying it's the implementation that's difficult about it inside the CDN, and so we have to do it, and we're going to get there eventually as well. But it's really just like the way it limits your ability to disconnect. Man, I'm trying to like how much to go into because it gets like into low-level networking details. But essentially, like if I wanted to do something like pass a TCP connection between servers, let's say. HTTP 2 makes that particularly difficult for me. HTTP 1, I can do that kind of thing without having to like sequence things. I can't really answer the question again. Sorry, I'm not prepared.
Do we have any final questions? Keep them going.
Nope, I think I'm done.
Brilliant. Let me come around to you.
So you talked about how you guys are working on new features, but your initial point was that like there's a bunch of configuration that people aren't aware of. Like, how do you go about mentoring and getting people aware of what they can do?
Yeah. So I mean, there's like the obvious things, right? Like having really complete docs. There's like really complete docs, tutorials, like good user experience for the app, which I think like the actual app that people are using to configure their CDNs, which is I think something that's been like pretty dramatically lacking in CDNs over the past like however many years. Like before we started Fastly, I remember trying to use CDNs in the past and just being like, oh my God, like why does this look like it's from the 80s somehow? But that's actually been improving quite a bit over the last several years across all of them. And so I think just like continued like, right, so docs, tutorials, good user experience in the app. And I think also like trying to do things that are shared across like the rest of the web, right? So like maybe the thing is like maybe we should be doing JavaScript at the edge, right? So then there would be less of a like learning curve for people trying to do that configuration. I'm not sure. Yeah.
Any more? I mean, I've got another one.
Okay.
Great. So we've discussed a bit about H2 here, and one of the new features that definitely were in none of the previous H specs was server push, which allows a document to also say, I also think that you should send these and give priority and weighting to them. But for CDNs, this is even more of a problem than just the TCP passing that you were just talking about. And because you're creating relationships between objects in the cache, and it's a nightmare. So how have you thought much about how you could even go about doing that in a CDN? And second kind of question as part of that is, what does that look like from an author's perspective, an application developer? How can I tell you as a CDN that I want you to push this resource with this other one?
Yeah. Okay. So this is kind of a pain in the butt to like connect all these like different pieces together inside the CDN, but this is actually one of the most exciting things about HTTP 2 to me, because not only are you guys doing server push from the origin, it also means that potentially we could be doing server push, not just based on what you say, but based on what we observe in the order and the latency and like the connections between objects as they're going out from our servers, right? So like if we see that like this request is always followed by this request and it's coming in over HTTP 2, we could do something really cool with that, where we like predictively guess what those users are going to need. That's not something we've implemented yet, but I'm really excited to do it at some point here. The other thing is, I'm trying to remember there's a spec out right now. There's a draft spec out for manifest for connected objects. I can't remember the name. Do you happen to remember?
It is basically that. It's the manifest, yeah. So
right. So basically,
it's coming out. The Google guys have implemented it first.
Yeah. Chatted with Souders about it a while ago. But basically the idea being that as a header or as like a meta field inside the HTML document, you'd be able to provide another document, like a reference to another document that actually shows what other things are associated with this thing. Like what are the most important things that should be prefetched? I believe it was like a prefetch manifest list, right?
Yeah, well, they're two slightly different things, but anyway, yeah. So there's the manifest, which would just be a JSON document that you can put inside the file, but there's also the prefetch and preload link element headers that you could actually set on your outbound headers. So then, you as a CDN could read the preload header. Yeah,
indeed. I think like those the easiest way that like people are going to start using server push is just connecting server push to those prefetch lists that people are already starting to use now.
So it's really interesting to hear you talk about you could preemptively do it without even us as authors saying doing that. But isn't that going to bring a lot of complexity? Because that's now state essentially for you guys at an edge where you never had state.
Yeah.
And you talked about you don't even want to go near GC languages, but then you actually want to introduce all this state at the edges. You know, it sounds like I don't envy your job.
No, I mean, like we hire a lot of very good low-level C engineers who can like work on this kind of thing. So yeah, it's exciting.
Perry, sorry, we're just having a chat here, you know.
Yeah, it's fine, everybody. It's cool.
I believe the pizzas are here, but Perry will.
No, the pizzas are here, as you can tell. Anyway, so are we all done? Right. I hope you enjoyed the night. So obviously, big round of applause for Tyler. So obviously now's the time where I just sort of like remind you about that Tuesday, April the 5th. Got Andrew Nielsen from Marks and Spencer's giving a talk. Hopefully in May, that I'm hoping that I get Jeff of the Cake here to speak, but he's being a little elusive at the moment. But that date is kind of blocked out. Anyway, hoping to see him on that at that 17th of March Google event, where I can give him a gentle nudge or more of a kick. But anyway, so thank you all again for coming. Hope to see you again at a future meetup. Enjoy having a chat, slice of pizza and a drink. The vegetarian ones are kind of like at the edge of the tables so that you can kind of separate those out if you need that. All right, and enjoy the rest of the evening. Thank you.